Okay, number 263, it says two parts to it. Find and identify the nature of any stationary points on the cubic of the cubic. How do we know it's a cubic? Look, the highest power of x here is a cubed function. And part B we'll worry about later. So what you could do with your graphing calculator is throw this in and see what it looks like. I'm just going to take advantage of this lovely program called Desmos, and straight away there be the answers. Okay, we're gonna find out these answers hopefully in a couple of minutes' time. But we have a maxima at 1, 0, that turning point there, and we have a what's this? We can say there is a minima. Okay, yeah, just to illustrate the point here, so we can say what are we looking at here? Y equals 0. Okay, and let's do another one here. We've got y. What was this one down here? It was negative 32. So nice numbers. Y equals negative 32. And let's keep the same tangent. Okay, so what's special about these turning points? As we know, stationary points have a gradient of 0, as in it's a horizontal line there. Right, so let's just find these points and lock them in. And how do we do that? Let's work it through. So the first thing we need to do is we need to literally find the gradient function. So fx notation, so f dashed of x is going to equal 9 minus 3x squared minus 6x, and that disappears. And what we're going to do here is make it look a bit nicer. Minus 3x squared minus 6x plus 9. We're going to put that equal to 0. Okay, and I'm going to times something by should we take common factor of 3 out first? Hang on, slow down. That's 2x and plus 3. So that just, and I'm going to, that just disappears. And I'm going to times everything by minus 1, x squared plus 2x minus 3 equals 0. And I think you'll agree that this is quite easy to factorize. We've got x plus 3 and x minus 1. Confirm that. Yep, that does work. Okay, and so the solutions are 1 and minus 3. Let's just confirm that. There, at x equals 1 and at x equals minus 3. So so far we've found the x coordinate, but I guess it says points. So first of all, let's look at let's plug x equals 1 into the original function. So we're going to say f of 1. So plug that into here. And what pops out? We get 9 minus 1 minus 3 minus 5. And as you suspected, it's 0. So the coordinate of 1 point is 1, 0. Again, what is it? It's that one up there. But if we didn't have a graph, Desmos or your graphing calculator, how would you know that is the maxima? Okay, so that is the key aspect here. The other point here, let's confirm that one. If we plug in f minus 3, this is going to be slightly harder, equals negative 27 minus, now that's going to be negative 27 as well, isn't it? Yeah, hang on. 3 times 3, yeah, but negative 27, those are going to cancel out. Minus, what's this? Negative 3 squared is 9, so that's going to be minus 32 there. No, sorry, minus, slow down. It's minus 27, lots of 27s happening here, minus 5. So that becomes a plus, they cancel, and you've got negative 32, which I think you'll find is what it should be down there, negative 32. So that coordinate is minus 3 minus 32. Now, how how do you establish the nature? You can look at the gradient function either side of the 1. So let's just do it that way. So, if you set up a wee little table here, how should we do it? So we'll say x, and we'll say f dashed of x. So here at point 1, what's something less than point 1? Let's say 0, and something slightly bigger, let's say 2. We know when x is 1, the gradient function is 0 there. So if we plug into the gradient function, when it's 0, what do you notice? It is 0, 0, that's positive. If we put 2 in, that's minus 12, it's going to be negative. So what does that suggest about the gradient? It's looking like this. So here it's 0, slightly to the left of 1 it is positive, slightly to that side it is negative, and obviously my apologies, can't quite see what I've just been doing there. That is a maxima. And if you did the same analysis over here for at -3, if you put -3, what's slightly less than -3? Well, it's going to be -4, should we say, and let's say -2, and the same thing is going to happen here. You're going to see like this. This is going to be negative, right? Negative here, and that's 0 at x equals -3, and on this side it's going to be a positive gradient. Now, folks, there's a lot easier way. I'm not quite sure, but the easiest way is to do the second derivative test. The second derivative test is differentiate it twice. So let's differentiate this again. What do we get? We get negative 6x minus 6. Okay, so that's the second derivative test. And what happens here with the second derivative test is you plug in your x coordinates. So at x equals 1, so double dash 1, what happens? It is negative. So the rule is if the second derivative test, if it's negative, therefore it is a max. You've just got to lock this in. And let's try x equals -3. What happens there? The second derivative test. What happens? -3, that's positive 18, so it's going to be positive. If the second derivative is positive, it is a minimum. And we've just done it that way. Okay, for what values of x is f of x decreasing? So what that basically says is do this. It says f dashed of x less than 0. Decreasing means the slope is negative. And it's negative like that. Okay, so at what points is it negative? So we need to take our gradient function there, and we basically need to tidy it up a bit. Let's just find some room in here. Where did we get? Oh, we got it down to this expression here, and let's put it like this. Okay, so minus 3x squared minus 6x plus 9, and we want that less than or equal to 0. Okay, we're going to divide everything by 3 again. What is that? Slowing down here, 2x plus 3, and I'm going to times everything by -1. So x squared plus 2x minus 3. And if we times something by -1, we've got to change the symbol. And if we factorize that, obviously we get x plus 3 and x minus 1. And this is fiddly. We need to do a number line here. How do we do this? Red pen. Okay, so at 1 here and -3, if we put 0, if we test number 0, which is between 1 and -3, put 0, what happens? 3 and what do you get? You get 3 times that gives you -3. Is -3 greater than 0? No. So that means that is the solution set that way. Okay, for what values of x is the function decreasing? And the answer is officially when x is greater than 1 and when x is less than -3. Sorry about that, can't quite see it. Hey, let's just go to the graph here and you'll see it pretty clearly. So the function said, yeah, so let's just put these numbers in here. Let's say x equals -3. Let's change the color on that one to, I don't know, yellow. Okay, and so this side here, anything less than -3, the gradient is negative. Agreed? Yep. And let's go on the other side here. Let's go x equals, what did we work it out to be? We worked it out to be very messily greater than 1. So if we said 1, change that to be yellow. So yeah, so somehow we're able to shade all this. This side here, any values this side, the function has a negative gradient. Therefore, it's deemed to be what we say is decreasing. Okay, and on this side, greater than 1. Anywhere between 3 here and 1, you'll notice the slope is positive. So that's increasing. Okay, that is the answer, and hopefully that helped you. But just to recap, we had to identify the points. What was the quick way of identifying it? The quick way, obviously, is graphically. You could see very clearly the answers. Okay, but that's sometimes not possible. So you have to algebraically, and how to do it algebraically? We differentiated, and this gave us a quadratic, which we were able to solve. And from here, we found at 2 points, 1 and -3, the gradient was equal to 0. And at 1, it just so happened that was the maxima point, and at -3, that was the minima point. And we were able to work out the coordinates of these 2 points by substituting x equals 1 into the original function. That's what we did here, and that gave us 0. And when x is -3, it was a bit fiddly here. We eventually got -32, and confirmation of that was this bit here. And lastly, part B, the function is decreasing, is when you put the gradient function less than 0. And basically, we could have used these values again, or we could have just looked at the graph here and said, hey, look, anything less than -3 is going to be a negative gradient. Anything more than 1 will also be a negative gradient. Cool.